So what are we learning today? We are basically learning about what are acids and bases today. So we'll see the definitions for acids and bases. We also learn about pH scale and indicators. So the observations and colors, etc. And what exactly does pH mean? In terms of success criteria, you need to be able to describe the definitions of acids and alkalis in terms of the ions that they produce when dissolved in water. The fact that when it's dissolved in water is very important. I'll stress on it in a while. You will need to be able to describe how acidity can be measured in terms of the concentration of hydrogen ions and how is this compared to hydroxide ions. Okay, I also need to be able to describe how acidity is measured in terms of pH scale. So the lower the pH, the more acidic it is, and also learn how to deduce the acidity of a substance by the observations of the indicator. So it is mainly the colors. All right. So um, yeah. So if you look into the slides that has been uploaded to you, and also be take reference from the theory book, you will need to open up your theory book to page 84 onwards. Okay, so let's get started. So what exactly is an acid? Okay, what exactly is an acid? You need to know that acid is defined as a substance that produces hydrogen ions when dissolved in water. All right, it is not sufficient to just mention that they produce hydrogen ions. It is very important that you mention that they are dissolved in water. And which is why a lot of times we always call or we always label acids. For example, hydrochloric acid, we would name it as dilute hydrochloric acid. So this is a very common name that you see in the bottles in the chemistry lab. So the fact that it's dilute means that it is dissolved in water, right? And similarly, we have dilute sulfuric acid, dilute nitric acid, and so on. So what is the importance of this water? All right, and what happens is that before there is water present, HCl exists as hydrogen chloride, which is a covalent substance. This covalent substance obviously is a covalent substance, so it is in the form of molecular, right? It's a molecular structure, and it doesn't have any hydrogen ions at all. Okay, so when it doesn't have any hydrogen ions at all, it does not have any acidic properties. So next time when if you may be wondering what is considered as an acid, you need to know that for a chemical to be considered as an acid, it must have hydrogen ions. So in this case, there is the absence of hydrogen ions. All right. However, once water is introduced to the hydrogen chloride gas, okay, it actually breaks up into hydrogen ions and chloride ion. So this is where our hydrogen ion is. And once this is present, we can say that it has acidic properties. Okay, so this process where a molecule is broken down into its individual ions, we call it dissociation. Okay, the process where a molecule is broken down into simpler atoms or ions, we call it dissociation. So a lot of times you hear us say when hydrogen ions are dissociated. So this is what it means. Okay, let me maybe write for you a bit clearer. Okay, so what is dissociation? It is when a molecule is broken down into simpler atoms or ions. We will seldom see the case of atoms in our syllabus. It's more so of ions. Okay, so you'll hear of this word very, very often in this chapter. So back to our definition of the acid, okay, which is why an acid, when you read over here, it says it's defined as a substance that produces hydrogen ions. And we have just gone through why is it that it must have water present. So this is the complete definition. And for a substance to be acidic, it must have hydrogen ions. Before that, hydrogen chloride, we can only call it as an acidic gas. So if I expose this to dry litmus paper, I won't see any observations. However, if my litmus paper is moistened with water, it will then cause a blue litmus paper to turn red because it will then contain water for it to dissociate into hydrogen ions and the chloride ion in this case. Okay, so this is the dissociation process and the importance of hydrogen ions. Other information about acids, we need to know that one of the physical property of acids is that they will taste sour. And I think a lot of you will have known this by now. Our citrus fruits like oranges, lemons, limes, all of them contain acids, and they contain mainly citric acid, which is why it gives it its sour texture, the sour taste. Okay, so this is what acid is, and these are some common acids that you will see in your syllabus. You will also see the first one, two, three, four, five. You more see the first five acids in the Sec 3 syllabus. The sixth acid called ethanoic acid is mainly seen in Sec 4. This is an example of an organic acid, and the other name for ethanoic acid is what we commonly know as vinegar. So if you have smelled vinegar before, especially if you have gone to Din Tai Fung and eat xiao long bao, you will definitely need vinegar, right? That is a sour tasting substance, a sour tasting condiment rather. Okay, so that is ethanoic acid. Back to the common acids that we will see in our syllabus. For now, you will need to know, by now you will need to know not just the chemical name, you also need to know how to form the chemical formula. So over here, I have broken down for you the positive and negative ions of each of these acids, right? A reminder again, they are ionic compounds and hence they have positive and negative ions. So for example, carbonic acid has a formula H2CO3. In this compound itself, it can be dissociated to form two hydrogen ions and one carbonate ion. So the two over here, the two over here, right, is where you get your two hydrogen ions from. Okay, and then um, for let me just change to a different color. Okay, and then subsequently you see for the rest, like let's say hydrochloric acid, there's one hydrogen ion, there's one H in the formula of HCl, hence I get one hydrogen ion, and so on and so forth. Ethanoic acid is a little bit different. Not all the hydrogen in the molecule is being dissociated to form hydrogen ions. So because it's a different type of acid, we call it organic acid. You will notice that the way it's being dissociated to form ions is slightly different. Only the last hydrogen at the back of the formula is dissociated to form hydrogen ions. The rest of it forms this ion called ethanoate ion. You don't need to know this at this point of time. You only need to know this in Sec 4. Okay, so this is in it. This follows what we have learned so far about the definition of acids, that it is a substance that produces hydrogen ions when dissolved in water. Okay, so that's where all the hydrogen ions are there for. Okay, so these are the common acids. And now let's move on to a base. What is a base? we have only learned what is an alkali in the past in Sec 2, right? In Sec 2, what is an alkali? An alkali is a substance, right? In Sec 2, we learned that alkali is a substance that is actually a metal hydroxide, and alkali is a substance that can react with acid in a neutralization reaction. So when we have acid plus alkali, I get salt plus water. This was what we learned in Sec 2, right? This is also known as the neutralization reaction. So but what are we learning in Sec 3? We are learning that we're not just learning about alkalis, but we're learning about what is a base. Okay, so what exactly is a base? A base is defined as a substance that accepts hydrogen ions when reacting with an acid. So here we have a reaction which is S base plus acid. It will cause the base to accept hydrogen ions. All right, and then they also say that metal oxides and metal hydroxides are bases. So here we see again, right, metal hydroxide, which is a type of alkali, and metal hydroxide appears here again. Okay, so what are common metal hydroxides that we are looking at? Example, sodium hydroxide, lithium hydroxide, potassium hydroxide, magnesium hydroxide. So any metallic hydroxides are bases. In addition, any metal oxides are also bases. So example, copper 2 oxide, magnesium oxide, aluminum oxide, iron 2 oxide, or so on and so forth. Sodium oxide, they are all bases. Okay, and actually, um, you over here you see that what is the relationship between an alkali and a base? An alkali is actually a base. All right, so first and foremost, an alkali is actually a type of base which is soluble in water. So not all bases are alkalis, but all alkalis are bases. What do we mean by that? If I were to draw a Venn diagram, right? If I were to draw a Venn diagram where the exterior is, or rather the bigger circle is base, a subset of it is alkali, right? However, what's the difference between alkalis and bases? Okay, alkalis are metal hydroxides generally, right? They are the ones that are soluble in water. However, bases can also exist in a form where it's insoluble in water. So that's why they say that not all bases are alkalis, right? Not all bases are alkalis, but all alkalis are bases. Okay, so this may be a bit confusing for you, but just have to know that alkali is a type of base. Okay, and in upper sec, a lot of times we will be referring to it as a base rather than as an alkali. Okay, because alkali is a type of base. What else do we need to know about it? We need to know that base alkalis generally have a bitter taste. People don't usually go and taste base, especially insoluble bases. But if they somehow go and put a little bit of detergent into their mouth, right, they would know that it has a bitter taste and it has a soapy texture. Okay, so this is more so for alkalis. So this is the physical properties. And common alkalis and common insoluble bases are over here. Okay, so in the next chapter of salts, you would know how to figure out whether a base is soluble or insoluble. So over here, I just quickly wrote for you. This is in relation to the next chapter. So generally, group 1 hydroxides are soluble. So I've got things like sodium hydroxide, potassium hydroxide, lithium hydroxide. They are all soluble. Okay. Calcium hydroxide is also soluble. Calcium hydroxide is our example of lime water. So if you recall, what is lime water used for? Lime water is used to test for the presence of carbon dioxide. Okay, and if it is present, we should have the observation of white precipitate present. Okay, you have done this before in Sec 2, done the practical before in Sec 2. So calcium hydroxide is also a type of soluble base. Ammonium hydroxide is also a type of soluble base. And there's also one more, which is barium hydroxide. So generally, the acronym to help you to remember what are soluble bases is this, is 1ABC. 1 stands for group 1, A stands for ammonium, B stands for barium, or C stands for calcium. So this acronym, you will see it again under the chapter of salts. Okay, for insoluble bases, they would then be the rest of the metal hydroxides that don't fall under this acronym, this category of 1ABC, and also the rest of the other metal oxides. So these are some examples. Okay, guys, do remember to fill in your theory book as we go along. So just now we saw the Venn diagram of the difference between a base and alkali. So we can see that the term alkali refers to bases, which are soluble bases. Okay, and so that's why all alkalis are bases, but not all bases are alkalis. So the common ones over here, these are soluble bases. So you will see that, you can see that this portion over here, these are group 1 hydroxides, because this is potassium, sodium, lithium, all belonging to group 1. All right, this over here is ammonium. Right, the ammonium ion, which is NH4 plus. You've learned this in the previous chapter. There is calcium, there is barium, right? So this is your A, B, C. Okay, and for insoluble bases, common examples: metal oxides, metal hydroxides. Okay, so what's a quick comparison so far of the summary of acids and bases? Acids have hydrogen ions, whereas bases have metallic hydroxides or oxides. Acids taste sour, bases taste bitter. Acids, in terms of the pH scale, is less than 7, whereas bases on the pH scale is more than 7. Effect on litmus: it turns moist blue litmus paper red. Right here you see again the importance of the water present. Right, if you recall just now we said under the definition, water must be present for dissociation of hydrogen ions to take place. Okay, and over here moist red litmus paper turns blue. Okay, so this is the effect of the indicator of litmus. Okay, so this is what we have learned so far for acids and bases.